Today we're doing DC generators and AC alternators. Okay, so the first thing we need to work out is that DC stands for direct current. And that also applies to the voltage. And we generally think that this means it's steady, but it just means really that it's going in one direction. It's not necessarily steady. All right, so AC means alternating. And that's like the power that we get from the power point. Current, again, also applies to voltage, and generally what this means is that it follows a sinusoidal wave pattern. So if we graph time against the EMF.
Would you like a walk?
So it seems very strange that you could actually get power out of that, but it does work out. Okay, so they are the outputs of these. Now I need to just make all of that disappear. So I'm going to do a trick with the camera. So what you have in these situations is two magnets with a coil in between. Let's go. So there you have it. So the magnetic field, the B field, will be going from this side to the other side, and these lines we draw we call flux, and they are going through the coil or threading it. I won't draw them in because it'll make it too cluttered. And this whole coil arrangement is turning. Now, when the coil is like that and the lines are nicely passing through it, we say it would have a lot of flux through it, maximum flux. But when it's turned a half turn, 90 degrees, then the orientation of the coil is in such a way that the flux doesn't thread it. So it goes from maximum flux to zero flux in a quarter turn. Now, depending on what's out here, connecting the coil to the external circuit will depend what sort of output you get. So if it is a split ring commutator, so we remember that that is a very important term to learn, split ring commutator. Then what you will get is DC, and if you have slip rings, unfortunately they have a very similar name, you will get AC, and you tend to not call that a generator, you call that an alternator. And the reason for that is what this is going to look, the output of this is going to look like is the EMF compared to time is going to be going up and down, back and forth. But on this side, the output is going to still be curved. I've forgotten how to do an E for a moment there. It's still going to be curved, but all of the curves are going to be rectified so that they're upwards. Okay, so you only get voltage in one direction. So the sorts of things that you have to consider with this are what is the frequency. So the period of one cycle will be whatever's on that time axis there, and then we work out the frequency by saying that's 1 over the period. And the sort of problems that we're going to need to solve will often involve using Faraday's law, the EMF is negative N over delta phi over delta T. So if you want to get a bigger voltage out of it, you can change delta T, but that will change the frequency. You could also change the amount of flux by changing the area of the coil or the strength of the magnet, because we remember that flux is equal to the magnetic field strength times the area. We could also change the number of loops on the coil. So they're the sort of problems that we have ahead of us.